Hello world and welcome to another episode of FooBar. In today's episode we are going to talk about monitoring and observability for serverless applications. If you want to know more about serverless, cloud computing or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Thursdays and on Tuesdays. I don't know why I said them backwards, but yeah, that's the point. So let's get started. So this is another episode in the series This Is Not a Podcast. Today we are interviewing Danilo. Danilo was one of the first persons I started following in the serverless community. That was one of the first persons I met from AWS, and I'm really a huge fan of his work. So I'm so happy to have him here talking about a topic that everybody is interested in, that is serverless, observability and monitoring. We will go into depth on CloudWatch and all the things that you can do. It's a long interview, but it's packed with information. So let's go to the interview and welcome to this episode. Today I have a very special guest. I have Danilo Poccia from AWS. He's, what is your new title now? You just got promoted.
Hi, Marcia. Hi. Hi, everybody. My most recent job title is Chief Evangelist for Europe, Middle East, and Africa. Yeah.
It's a very important title, so congrats on that.
Thank you. Thank you. It's been a long ride.
I know. I met you many years ago, and you were one of the first faces from AWS I met, and I'm really happy that you're here today. It was Serverless Conf 2016 or something like that in London that you were there.
Yeah, I think.
Yeah, and I was just starting my YouTube channel, and then this random person, hey, you have a YouTube channel. I was like, yeah, it's like 4 persons and my mom that follow me. And I was like, wow, somebody recognized me. So it was, I will not forget that.
But it was really the beginning of serverless, no? It was time when you were writing serverless, the computer was correcting you and saying, no, it's maybe server-less, because serverless as a word is not a thing. Yeah.
It still corrects me all the time, so one day Mac will learn about serverless and not say server space less. So maybe we can start a little bit with the topic of today, that is observability. And you have been talking a lot about this topic lately. And for me, when I did my first serverless project, we so failed at observability and think, well, in 2016, when I was doing this project, nobody has the idea that observability in serverless is so different than in traditional applications. And I would like to hear your take on why observability is so important in serverless.
Well, if you have a traditional application running on a couple of servers, no, we used to the term monitoring. You just monitor that the servers are working, your application is working as expected. But now we use the term observability because things are much more complex. Because any architecture, if you're using serverless containers, you start to have lots of moving parts that communicate with each other, and you really want to understand what they're doing. And serverless is, in some way, it's making this even more important, because I remember I was like at reInvent last year, I was doing a presentation with the people from Lego with Shim Results, and one of the use case that they were presenting with serverless was a simple checkout application. So you have an e-commerce and you need to do a checkout. So you have an API gateway, you have a couple of functions that you use to get or write the state of the order, and then you have an SQSQ, and then you have another Lambda function processing the order when it takes more time, a DynamoDB table. So every simple use case has so many moving parts. And the side effect is that if something happens, so for example, at some point your API starts to be slow, how can you understand where this slowness is originating? You really need to have lots of information and be able to correlate all this information quickly to find the root cause. So that's why you really need to think this straight. Any serverless application, unless it's really one Lambda function and API gateway, you need to understand the moving parts and you need to collect and process this information.
Yeah, and also I think the idea of following one kind of message through all the different services and steps is so complex. It's not like it's inside a box and you can go into the code and debug step by step and try to understand what is going on. With serverless, you have all these distributed systems doing their thing, and maybe you have an event-driven architecture where events are listened by multiple things at the same time. So it's a lot of, I think observability becomes very critical there in order to have the tools in place, at least. In my experience, when I didn't have a proper observability and monitoring thing in place, we suffer a lot.
Yeah, and so you mentioned these tracing capabilities, but no, when we talk about distributed architecture, probably the first time that I really dive deep into these topics was when microservices start to be used a lot, also by the customer I was working with. So I start to study more on the topic, and with microservices, normally you want to have these microservices independent from each other so that everything can develop and deploy. But there is one thing that you need to standardize, and it's logging. Because if everybody logs in their own different way, then you really can't understand and match things together. So this was probably the first hint that something was changing. Now that teams can develop independently, but there's something when you start to look at how things work, like logging, where you need to have a standard. And
also with serverless, I think at the beginning of the story, everybody was wearing a lot of monitoring Lambda, because that's where you were putting the code. So that's where you have to have all the logging and the monitoring, and maybe other serverless components didn't have much capabilities to display their monitoring or to connect that well to your monitoring system. And that was very confusing, because if you were using all these services, then you were like, now I think it changed, and most of the serverless services have this built in. But at the beginning, it was really hard.
Yeah, absolutely. One of the last services, for example, that start to integrate with a tool like CloudWatch Logs was a step function. So it's something that a couple of months ago we integrated. Before you would have a different way of finding those logs, and I think logs is really something when you whatever tool you use, you need to have a standard across all your company.
Exactly, and I think if you're using AWS, CloudWatch is like maybe the first place you're going to go and check your monitoring. So, what is CloudWatch? Maybe we can explain a little bit on what are the different parts of CloudWatch and what it's inside. Because I think I never mentioned that.
CloudWatch, CloudWatch is I would define it as our monitoring platform. And it is growing a lot. So we are adding a lot of features and also new components to the CloudWatch platform. And sometimes I see that some people they get that you can get maybe interested in new announcements that are completely new, but you lose track of all the announcements that we do on CloudWatch because you think, oh, that's boring. Actually, it's really interesting to follow that, and it's the origin of this dive deep that I did more recently on observability. So first of all, CloudWatch can help you with what we normally call the 3 pillars of observability. It is logging, it's metrics, and it's tracing. So these are the 3 pillars that you should think of building and probably standardize across your distributed architecture, being it serverless, being it containers, be it a mixed architecture, whatever. So logs, as I said, you need a standard, and probably I would write something that is semi-structured, so like JSON. Probably today, if I need to start something new, I would use JSON as the format for logging, not free text, because you don't want to search strings. You want to have something that you can process in a better way. And so CloudWatch Logs is an interesting tool that we're improving a lot. Just yesterday, I noticed that we have a new console. So that is simplifying some search. So when you search the log group for a Lambda function, you can finally search easily for the right log group of your Lambda function. So it's improving in also in usability.
Yeah, because at least it's always a little bit scary when you go to CloudWatch for the first. At least for me, it's one of the few times I need to go to the AWS console to check the logs, and to check the CloudWatch. I do everything else from my terminal. So for me, it's like an adventure to go and try to find sometimes the logs. If I don't know the log group, then I have to click 27 different places. So it always daunts me for me, CloudWatch. And I imagine to many people that are used to do everything programmatically, so
Yeah, CloudWatch console is huge, no? Because you have the CloudWatch metrics, the CloudWatch alarms, the CloudWatch login sites to search logs. So each of these components is like a separate interface. So you shouldn't be scared because you should just learn by necessity. No, when you need something, you go there and you probably find the feature that you need. One thing that maybe some people is underutilizing in some perspective is the dashboards that you can create with CloudWatch. So now almost everything that you do with CloudWatch, it can be an alarm, it can be a graph, it can be a query that you run with the login sites. You can incorporate that into a dashboard, and this is the idea is that you have your team dashboard that gives you all the indication if everything is going as expected. And that's a good way to simplify things, because then you don't need all the people in your team to know everything, but you have this dashboard with all the indicators, alarms, graphs. Then you can click and then go into the component if you need.
And you can always create, one of the things I like is the custom metrics. Like I used to create business metrics with the custom metrics, and then I display them in the dashboard, and they were talking more my language than like the Lambda invocations maybe didn't tell me anything. But if I knew how many customers were doing X, I know that's under expected, and that's good. And I think that's something really, really easy to do, at least with Lambda and CloudWatch. It's so simple to just push custom metrics and draw them in the dashboards, and then you can display them in big screens and people can be aware.
Yeah, no, this is another topic that I always talk with people, because people looks at the classical platform metrics, the latency, other metrics like CPU usage or these kind of things doesn't make really sense for Lambda or serverless. But this is what the network usage. But this is not telling you if your application is working, no?
No.
So normally I got inspired on this by Nora Jones. No, she used to work for Netflix. She's an expert in chaos engineering, and she was talking about how they do deployments in Netflix, and she said, no, we always look at the number of play per second, the number of people clicks the play button on all the multiple platforms that you can use to watch Netflix. And if a deployment is affecting the number of play per second, there's something wrong, no? Because you're not changing the behavior of people immediately. And if this is happening, then they roll back and then they investigate. So normally what I suggest is look for 1, 2, maximum 3 business metrics that describe if your application is working, something like transactions per second, or the number of search in the product catalog, if you have a catalog, something like that. If this is changing unexpectedly, then this is the best indicator that something is not working as expected.
Exactly, we were using that, and also we were creating alarms towards those things in the projects I work with serverless. So that it's a great way to know if something is kind of wrong, if something goes out of the expected targets. Either, I don't know, if you have an e-commerce and everybody's buying, that's good. It's a good alarm to wake up for, but maybe it's also good to investigate that if somebody's hacking you or something is not really right. So for me, always these business metrics are always like the easiest to also explain to others that are not maybe developers and maybe are managers or not technical people as well, that they can be aware of.
And we also made it much easier to create custom metrics now, because last year we launched we call them embedded metric format. And basically, if you write to CloudWatch logs with a specific JSON syntax, we understand that you want us to take these numbers and transform the log into a metric. And to make it even easier, we have some open source libraries for Node.js and Python. So with literally 2-3 lines of code, you can create a custom business metric to publish the number of things that your application is doing, like number of orders that you're processing every minute or something like that. And it's super easy to use. You don't need to aggregate data, something that is always complex in a Lambda function, because you just write on the logs and we do the aggregation and everything for you. So I think this is something that can really help create business metric in an easier way.
Yeah, and the cool thing of CloudWatch and using these things is that you don't need to import anything. It just works directly from Lambda, so you don't need to add any extra latency to your application. One thing from metrics that is always confusing maybe for the persons that are watching it for the first time are these P numbers. What it means? Because it's one of the first questions whenever I talk about metrics.
Yeah, so P numbers are really useful to monitor this kind of some kind of metrics like latency, for example. And now, if you have a very large service, take for example our auto-scaling API. What's the maximum latency that you can expect from our auto-scaling API? You can think maybe it's 2 seconds, it's 10 seconds. Actually, what we learned is that there's some people that in this auto-scaling group, where you manage a group of virtual server, you can have a few servers, like most of the people, or you can have tens or thousands of servers. So of course, if you call the auto-scaling API with this very large group of tens of thousands of servers, it would be slower. So you can set a threshold. You really need to understand the distribution. And that's why we use internally in Amazon the P numbers that actually are percentiles. So for example, the P50 is telling you the number where 50% of the observation are below this number. So the observation can be the latency. That means this is the latency that 50% of the user of the are experiencing. And the other 50 is experiencing something higher. And this is much better than traditional approach like average. So for example, if you have the P99, that is probably the first interesting P number that you can use, it's telling you that 99% of the user are experiencing something that is this latency or below.
Exactly.
And only 1% is above that. If you take an average, for example, an average is telling you, that half people is slower and half people is faster than this average, but it's completely useless.
Because if the outer layer, like the outer number is too out, then it destroys all your average. So these P numbers are always really good to see more or less. Okay, P95, P99 is maybe where you want to look.
Yes, P99.9. Depending on the amount of numbers that you have, you can go P99.9, even P99.99. And the reason is that also people is interacting a lot with your API. So if you're a customer interacting with an application, maybe you call this application 100 times in a day. So if you look at the P99, then already there is the probability that one of these invocation goes above that.
Exactly.
So you really need to be accurate, because it just needs for your customers to have a bad experience to start to say, oh, maybe this application is not good enough, I will go with this other one that is faster.
Oh yeah, that's true. And another thing that I like that it was launched, I think, last year in re:Invent is the anomaly detection, or it's older, but I think it's quite new.
Yeah, so we launched officially in general availability in September, so a couple of months before.
Somewhere.
Yeah. And there were some months of public preview before, and yeah, I really love this feature, and because it's basically another side effect of serverless is that, okay, I have maybe 10 functions, lots of services that I'm using, so I'm collecting all the metrics. But now I have too much information. So how can I understand if things are working as expected or not? No, it's the opposite problem. It's not that I know everything, but then I can't really, with my human brain, understand if everything is working. So that's where machine learning can help. Machine learning has a long history of anomaly detection algorithms that can look at a series of data and understand if there is some unexpected behavior. So it can be an outlier, it can be that something is not going as expected. So now CloudWatch, you can, on any metrics that you collect, can be a custom metric like your sales per minute, it can be the latency of your API, you can enable the anomaly detection. Is literally one click in the console. And then we use the last 2 weeks of data to understand what's the expected behavior, and then we will create basically like a band around your metrics, telling you, okay, this is where we expect your value to be at this point in time. If you go outside or below this band, you can create an alarm and get a notification. In this way, even if you have thousands of metrics, you can always be notified if something happens that is not expected.
And I think that's really good, because at least in most of the service there is traffic patterns. Maybe if you're, I don't know, Netflix, maybe they have on the nights, and in the weekends they have way more traffic. So if you create an alarm, it's very hard to know, but if it's on a weekend, then how, like when you use anomaly detection, then you have this band that moves maybe accordingly to your expected patterns of the users, how they work with your application, if they use it on the weekends more or in the Mondays, or I don't know. I imagine everybody needs to unlock it for I don't know, Black Friday, because all their anomaly detections will explode if it's only 2 weeks of them.
Yeah, you can actually say this period, just don't consider this period because it's an outlier, because it's Black Friday, it's Christmas, it's another public holiday, so it's screwing up all the numbers. But it's really definitely something you can do. You can also set actually the time zone, because when you have the daylight saving time, and we switch from summer to winter, you have this 1 hour of difference that can again change all the expected behavior of your, because you're selling 1 hour before or an hour later than expected. So you can put that into the anomaly detection and tell, this is tied to this time zone, so that you can understand if things are going as expected when we switch from summer to winter or back.
That's cool. I have not tried the anomaly detection, because I think by September I was already working in AWS, so I didn't have any customer projects.
Yeah, it's not something that is easy to test, because you need data. So it's not something that you can create like a pet project. You need some real data. And another thing that you can do with anomaly detection is set the width of the band, of the setted band. And you use the number of standard deviation. So in statistics, the standard deviation is telling you how broad or not is the expected distribution of your values. So you can use, for example, 1, 2 standard deviation, and then you could probably get what is called a false positive. So you get an alarm, but it's really nothing strange is happening. But if you start to get 3, 4, or even 5, up to 6 probably standard deviations, then you get alerted really if something strange is happening, if your values fit a normal distribution.
Yeah, but I think that's very important to have in mind in general with any alarms, that if you get alarms when things are not really happening, you will stop paying attention to your alarms. So I think it's very important to have a reason why to have an alarm and be very conscious on it, because it's the more alarms you have, it makes people more insensitive at them. If they just go and there is nothing really to worry, then it's just always dangerous.
Normally with anomaly detection, I always suggest start creating the anomaly detection, and maybe create an alarm that is not connected with anything. Maybe you just get a notification via email, so you start to understand if it works or not with your use case, because machine learning can be dumb. So it's if your numbers don't fit the model, then it will not work very well. So to start in this way, and then when you see that actually every time you have a problem, the anomaly detection would catch it earlier, then you say, okay, I will enable this, and then I want to have it bang in my dashboard if something is going not as expected.
Yeah, and also machine learning needs training, so you cannot expect that it works on the day one. Maybe you need a couple of days or months or whatever. I don't know how much data it needs to ingest to become stable and to.
We always use 2 weeks. So you need a few days to start to have some patterns, and when you have the last 2 weeks full of data, then it starts to work well.
Yeah, so that's more or less all I think we talk a little bit about all the features on CloudWatch and metrics, didn't we? I think we cover most of everything. Maybe we can move to CloudWatch logs, that I think is the most used feature in Lambda development, console.log, or whatever language you like to use.
Yeah, so one tip is that both SAM and also with Serverless Framework, you can get the logs on your terminal, so you don't need to go straight in the console. So it can be, so if you are used to develop with multiple terminal screens and one is tailing your log, you can do something similar, for example, with SAM. And you can get a little bit of delay sometimes, but it's a distributed architecture. But this is something that you can still fit to your normal development routines.
Yeah, and there are many open source projects that also help you with this. I was talking last week with Ben Ellerby from Theodo, and he built this open source project that it shows like a huge console for managing your lambdas from your terminal without going anywhere. And there he also had the logs, but I think you can choose what tool you like. There is also Visual Studio, code plugins. There is so many ways that you don't need to really visit the terminal to see the logs and to tail them. That's always important, so you don't need to go and click refresh. How many times we have done that? But I think the CloudWatch logs, they have also these insights now, and maybe we can talk a little bit about what are those, because that's something quite new.
Yeah, so CloudWatch Insights is something that we launched, not this reinvent, the reinvent before, and it's a way to query your logs. So your logs must be in some structured, semi-structured format. So normally I suggest JSON, and then you can run queries. And we also have standard queries for the normal logs from Lambda functions, but also from other services like the VPC flow logs or CloudTrail and other things that we can write on CloudWatch logs. So if you use this, you can run queries. Maybe I can show a little bit the console here because
we can show stuff.
So this is the logs and the log groups. So this is the new console I was mentioning before. Now you can now finally search freely. So for example, I have an observability demo, and you can just search and you find all the logs. So these are 3 Lambda functions that I use in my observability demo. So let's say I want to run a query on these 3 log groups and all the logs within this log group. I can just click here, query log groups. This goes into CloudWatch logs inside, and here we have standard queries for Lambda, and as I said before, around 53, AppSync, other tools. So for Lambda, we have some standard query. Let's say I want to see if I really use the memory that I provision for my function. So let's click here. This is a query that is, let's make it a little bit more visible, that is looking into the report line that we write at the end of every Lambda function invocation on CloudWatch logs, and it's taking the amount of memory that is being provisioned and the one that is being used in average, and the minimum and the maximum. And then it's doing the let's go and let's take maybe the data from the last couple of days. And
yeah, but this is something super useful.
Yeah, so here you see when some data was collected and the amount of memory that was used, and here you can see now how much it was provisioned. And normally this is a very simple application, so I was giving 128 megabytes, that's the minimum, and I was using something between 87 and 95 megabytes. So there's nothing really interesting to discover here. But if you have some largest or smallest function, you can of course over provision memory to get more CPU, but this can be a good indication of what you're doing.
That's cool. And there's many queries there that you can try out. For example, the latency.
Yeah, so this is the latency statistics in 5 minutes interval, and then you can display here. So the syntax is really easy to understand. So I never remember the syntax if I need to write a query from scratch, but
no.
When you have an example, is not difficult to find. Like this is the size of the beam, it's every 5 minutes. This is the average max and minimum duration, and you run the query and you get the result. And then if you customize, you can now, this is something that we launched very recently, and I was super happy because someone asked for this feature a few days before we launched it. You can now save the feature. So let's say I want to have 10 minutes bins, and I can save it. You can do this. This is the latency for 10 minutes bins. and then you can optionally create. And this is already tied also to the log groups that I want to use. So I can save it, and now if I go here, I can see the queries that I saved, and I can find it. So it's a good way to optimize your routine.
Yeah, because there's many queries that you do over and over again, so it's good to have them somewhere easier to access, not in a notepad. That's I imagine where everybody keeps them.
So definitely CloudWatch Insights is a very interesting feature that and it's changing the bar. So before you always need to use a tool like Elasticsearch to analyze your logs, but now depending on your use case, you can maybe be okay with this, and then you don't need to set up an external system.
Yeah, and I like that direction that AWS is taking, that because if you have a serverless application, you don't want to have an Elasticsearch cluster just for your that was one of the things that for me was very annoying when I was doing my first serverless project, that where I can see all these things, I need to set up all these servers just to see the logs of my serverless applications and to be able to analyze them. So I think this is very, very good. And as you say, if your search are not too weird, I don't know, I have not tried in real projects these insights, but at least it seems quite powerful, all the querying that you can do, and all the experiments I have run, it always helped me a lot. So I think it's it's something that help out a lot, and you don't need to have your Elasticsearch just for your logs. Yeah, I think that's the wish list of a lot of serverless people. Elasticsearch serverless. Yeah. Maybe one day. And then the last pillar is tracing, and I think that's something that is very critical and very different in serverless applications, or I think it's very common in distributed applications, but it seems that serverless and distributed are closer together than traditional applications. And tracing is something that I don't know. I think it when you start developing serverless applications, you don't realize how important it is, and then one day you have a problem and you realize you have never enabled it, and you're screwed somehow. And so maybe we can talk a little bit about tracing and what is the biggest problems and how AWS can help us.
Yeah, so tracing is something that start to be very popular with microservices and that made distributed architecture so popular. And the first approach was, okay, I need to build some correlation between my logs. So every time I get a request from outside, my first interaction, like normally something like an API gateway, I will add a unique correlation ID to this request, and this correlation ID will flow through all the different microservices and processing, and then I can correlate all these logs together, searching for the same correlation ID.
Exactly.
And this was the starting of the idea. Then we had open source projects and staff building and increasing the landscape of tracing, and we also launched our own platform on AWS. So again, with the idea that you don't want to manage a tracing system, you want to just use it as much as possible, and that's AWS X-Ray. With X-Ray, you can enable it. You can just enable it for Lambda, for example. You can enable it for the API gateway for REST APIs, and then you will get what we call segments. So every time a Lambda function is called through an API gateway or from other services, you will get this segment that tells what the Lambda function is doing, how much time is, for example, if there is an initialization phase, how much time is spent in the Lambda platform or actually in the execution of your code, and so on. But for really getting good information from tracing, you need to instrument your SDKs so that when the code in your Lambda function is calling, for example, S3 or DynamoDB or other services, you also get and correlate together these invocations. And to do so, you need to use the AWS SDK, the X-Ray SDK together with AWS SDK. So it's depending on the language you use. You have plenty of examples on our documentation, but it's sort of wrapping. That means that every time you call the AWS SDK, for example, you call S3 or DynamoDB, actually you go through the X-Ray SDK that will write down the timing of the start of the request and then when you get the response. And all this information is then collected Normally with tracing, you don't want to collect all. You want to work with samples. Depending on your volumes, you want to set like collect this amount, and then if I go above maybe 100 per 1,000 per minute, I just want to get 1% or 2% of the invocation, and then you can use this information to visualize what is happening.
Yeah, and I think that's the first time you open X-ray is maybe a little bit confusing, but when you start learning how it behaves, it's super useful to understand if you have some delays or latencies or things that are not really performing very well, or if your message are getting lost in the whole thing. But then we have service lens, and if you look at service lens and X-ray, they look very similar. So what is the difference?
So maybe again, showing the things is easier than explaining it. Okay, so this is the CloudWatch console, and now we have service lens here. But to understand what service lens here is, let's start with X-ray. So this is X-ray that is collecting the information. So I have a serverless app that is composed of a few Lambda function, and there is an API gateway that you can see here. Then there is a couple of Lambda function, then there's DynamoDB. So it's really making visual the architecture as the data is collected. And now everything is green because there's no problem. But for example, if one of the Lambda function is experiencing some errors, or the DynamoDB table, you run out of the throughput you provisioned, you would get orange or red colors that tells you where the problem is originating. And this is X-ray, but you can see all the data that X-ray is collecting. For example, this is the distribution of the response time for multiple invocation for this Lambda function. But this is not correlated to the logs of the Lambda function. So what we wanted to do, and what we did with Service Lens, is to put together the information with X-ray, the information that you have from CloudWatch logs, the information that you have with CloudWatch with all the metrics that Lambda, DynamoDB, API Gateway are publishing on CloudWatch. So if I go here, I can build again a similar service map. There is also a nice full screen view where you don't get any, you have the full screen at your disposal. Now, if I click on a Lambda function, you see that I get not just the information that X-ray has, but also the metrics of the Lambda function, like this is the latency, the request, if there have been errors, and I can then jump straight to logs. So if I click here, I go again back to CloudWatch log insights with that logs of that function selected, and I can now run a query and analyze the behavior of that specific function, and I can also see the logs here as they have been processed. So it's really putting together all the information that you have from X-ray and CloudWatch in a single place. This is really something that we got lots of requests, because when you do root cause analysis, you want to be able to drill down. You don't want to jump from one console to the other.
No, and I think this is super useful for that reason, because it's like sometimes you have so many services that you're using, but as you said at the beginning, you want your logs and your monitoring to be in one place. And I think it's nice that everything now is under CloudWatch, basically, that you can just stay here. Yeah. In general, if you have an error, you're already in a panic mode to start figuring out what is the right place to go. It's always like you're stressed enough. So it's
normally
nice
what I suggest to avoid that is create playbooks. No, every time you have a problem, you should analyze what happened and create a playbook, because it's really not the time you need to invent something. It's you really need to execute something that has been planned before.
Yeah, but that's I think a discussion for a different talk. How to handle errors in production. That's and I think more for companies adopting serverless, it's always like maybe the first time seeing some errors or experiencing this new word, and I don't know. It would be nice that there are some playbooks to download.
Yeah. The fact that you cannot SSH into the server is always something that people get frustrated about. But over time, you appreciate that you don't have to look into that side of the things. You can focus on the application.
Nowadays, it's been so long since I don't write a traditional application that I will not know why I would like to SSH to server anymore. It's just like, I don't know. I don't feel the need. At the beginning, it was very confusing, but now it's just like, why I used to feel like that? And the last bit, I think, of CloudWatch that we need to cover is the synthetics. I don't know how to pronounce that. Synthetics, CloudWatch Synthetics. What are those? That's something new.
This is something that is, it's been available after reInvent and is now also generally available. It's what is normally called synthetic monitoring. I normally like to call it also synthetic transactions. And this is something that, again, came out when we start to have this distributed architecture with microservices. Normally you focus in testing, in doing integration tests with each microservice, or in the case of serverless, maybe each Lambda function. But what happens when you test everything together? When you have maybe 10 services, 100 services, or you have maybe 1,000 Lambda functions that work together across different applications. You can't trust like simulated environments. So the simplest things that you can do is create some synthetic transactions. So some transactions that are not real, but will simulate what a user would do, and go across all the services that compose your application, multiple Lambda functions. They will read or write even from databases, and then you get a result. If you do this periodically, you can test that everything works. So for this is something that before you would have to implement yourself. Now you can leverage this framework that we created. So maybe again, I would like to show the console because there's some real value in how this works. So
if you are not offering to show the console, I will ask you because this sounds super interesting.
So this is, again, the CloudWatch console that, as I said at the beginning, is huge. Now you have these synthetics here, and you can create canaries. So let's create a canary. How can you create a canary? You can basically when you create a canary, you can create a script that will run periodically and will simulate some monitoring, the synthetic transaction on your application. So here you really don't want to test a small part of your architecture. You want to test the external interfaces, the endpoints of your application. So if you're an e-commerce platform, you want to test what a customer would do if they add an item in a shopping cart. You don't want to simulate the shopping cart microservice only. So we have some blueprints that can help you start with a script. The script is just JavaScript, so it's easy to customize for most developers. So we can give you a blueprint that will just test with an heartbeat if a page via HTTPS is working. You can test an API, and this is something that I normally like to do. So you can, for example, say I want to simulate an HTTP GET or an HTTP POST, and this is my API endpoint. And then you can add the data for an HTTP POST. You can add your specific headers. So sometimes, for example, if I'm simulating an e-commerce platform, and I want to simulate an order, I don't want actually to complete the purchase and ship the product every time. So you can create an header here that tells you that maybe this HTTP request is a simulation, and then you can use this to block the final part in your application. So this is something that is quite common. And then if I select this, I get this standard code that will run this HTTP GET or HTTPS as it probably will be, and will check that everything works as expected. And then we have more advanced blueprints, like you can test if there is a broken link in a web page. So it's basically a crawler that will test all the links of your application. And then the final step is the more advanced one, is simulating a user interface interface with multiple steps. So maybe you have a web application where a user needs to log in. Then when they log in, they search the product catalog. Then they add some products to a shopping cart, and then they do the payment and do the checkout and whatever. So here you can really do so, and we provide you a standard script. There is Synthetics is bringing you a library that helps you simulate the steps that the user would do. And you complete everything. And then when you have this blueprint tailored, you can run it once, or you can run it continuously, like every 5 minutes, every hour. And then you can, for example, set up a timeout so that if something doesn't work, it will end. You can set the retention for the log that we write on S3. And then you all the other configuration. You can say, okay, in case this fails, I want to be notified with a CloudWatch alarm. Or I want to configure this to work in a specific VPC because it's not an API that is exposed on the public internet. Yeah. And in this way, you create your canaries. And this is, for example, a couple of canaries that I created. And I didn't schedule them, but I can always run them. And if I start them, this is testing with an HTTP GET that my API is working. And normally it takes just a few seconds to start. And then it will, okay, it's the last test has passed, so everything works for my synthetic transaction. So I think this is the ultimate step in observability, but it's really simulating not the internal things of your architecture, but it's simulating what from the outside your customer would experience. So it's really important to have this periodically running.
Yeah, and I think this is really a great thing that complements also with deployments and with the other, not observability part, but the other part of delivering these services, that you might have multiple teams working on these things and you want to have continuous deployment, everything independent, but then if you have this canary running, then at least if you have them maybe in your production environment, but I imagine you can also run them in your testing environment, and you get maybe the alarms if some deployment doesn't go.
Yeah, definitely. I think pre-production is also a very good environment if you want to run this, because normally you have everything similar to production. Exactly. But the ultimate step for me is really to run this in production, maybe with some headers that tells don't actually do stuff like if this is a real user. But I think this is really important, because otherwise you don't know the experience of the customer. Now you don't know if something is going slow, and all the other bits that we talk today, the logs, the metrics, the tracing, they are good to analyze if a problem happens, but this is really the best tool to understand if something is not working, similar to the business metrics that we mentioned before.
Yeah, definitely. And I think it's good always to have these things in place that are, because you cannot be looking at your logs or dashboard all day, so you want to have reliable ways that you get notified when something is broken, and this is one of those reliable ways. If you have these flows that are kind of very important to your organization and they are working slow or they are not working, then if you get an alarm from there, it's something very kind of clear that something is not working, and you can go and check it out. And it's also very simple to set up, because this is something you can also write with a Lambda function maybe, but then you need to manage the Lambda function, and you need to monitoring, and you need to monitor the Lambda function, like it's kind of an endless loop of who is looking at who. But if this is built in the platform, at least you can trust that it will be as working as all your other logs and all your monitoring systems. So
and if you want, you can even do this cross-region. So you can, maybe my application is deployed in Ireland, and then I deploy this in Frankfurt. I configure the synthetics transaction that tests the application is working, so you can decouple the everything from the region where your application is running.
Exactly, and I think it's really simple way to just write a script, and if you can write even these user interface scripts, that's super powerful, because then you can really have the end-to-end experience from the front end until the latest layer of your application.
Yeah, and the blueprints we provide are so easy to customize. So it's not really that you need to create something new from scratch. It's just a little bit of a customization. So, and if you test, for example, an API, you can really go with the default scripts.
Yeah, I imagine, but usually people always have some weird things, but I imagine there is some documentation that they can read on these synthetics somewhere that will help them to build their script with all the weird...
People love reading documentation.
Oh, yeah. It's their favorite part, but sometimes people have a lot of weird desires, and they make sense, so that's the nice thing of scripting, that you can do whatever you want. So I think I imagine there is some synthetic API or something that can, or SDK or something like that.
Yes, there is an SDK with all the documentation.
Yeah, exactly. For all the people, but I will link all that. I will look for it and link it in the description box so people have a fun that we can read in the Synthetics API documentation. Cool. Yes. Do you want to share something else about observability? I think we have covered at least all the new things in CloudWatch and some of the old things that are classics, and we have talked a little bit about everything, and I hope people now are a little bit more aware of all the power that there is in CloudWatch, because it's not only logs.
Yeah, maybe the last bit is if you use serverless and you build an event-driven architecture and you use, for example, a platform like EventBridge, that is one of my favorite new launches that we did in the last years. One thing that you can add is store all your events, because the events that tell you the story of your application. So if you have an event-driven architecture, storing the events allows you to understand what really happened, and also starts to prepare you to the idea of also replaying maybe the events in another environment. Like I store the production events, I make them anonymous so that I remove credit cards and data that shouldn't be moved outside of production. Then I can rerun the events in a test environment, and that's very good because it can help you test if you solve a bug, if everything works as expected. Regression tests are super easy to do. So think that storing events, it's again helping you to get more observability because it tells you the story of your application.
Yeah, and I think that's something so easy to do with EventBridge. When you have a full event-driven architecture, it's so simple to just store all the events. It goes to S3 and you don't have to do anything. So it should not be a big pain to store it and then look at them and, as you said, replay, and you can play with your production environment in a sandbox and nobody gets affected. And so that's a good tip. But yeah, I think if you have some links for us, I will get them for you about all these services. I imagine there is many blog posts and documentation you can share with us so people can dig a little bit more into the depth of all these services. But I don't know where people can find you after we finish talking.
Oh, I'm not difficult to find. So I'm mostly active on Twitter. So I'm Danilo on Twitter. And normally it's the fastest way to interact with me. You can find me on LinkedIn. You can find me on almost any social platform. And a tip for people that arrives to the end of the video is that my email at amazon.com is the same as the Twitter handle.
Are you sure you want to say that?
So we will see how many people goes up to the end of the video.
You never know. Well, that's good. So yeah, that's it for today. Thank you very much, Danilo. It's always a pleasure to talk to you and now to share all this observability knowledge. I think I have a lot of things to try because it has changed so much since I run a production system with CloudWatch that I have some homework for me. So now I'm inspired to try these things. So thank you very much.
Thank you for having me, Marcia. It's really a nice chat. Thank you.
Thank you. That was the whole video for today. I hope you like it. If you did, give a big thumbs up. Remember, in my community tab, in my YouTube channel, there is always a poll on the persons I will be interviewing. You can go and put questions for some of the guests. So do that if you want to ask particular questions to particular guests. I will be asking those questions to them. So if you want to find any of the links that we talked with Danilo, they are all in the description box, and as always, and you can check them out. And I see you in the next episode of FooBar. Ciao, ciao!